Hey guys, welcome. This is our question set 2 answers. So our first question set is algorithm heuristics. So just an FYI, heuristics is the ability to problem solve something that, it's problem solving something that is almost impossible to solve a problem. So we come up with an approximate solution. So that's what we're doing here. So and you'll see that in the questions. So which of the following situations would be it best to use a heuristic in order to find a solution that runs in a reasonable amount of time? So finding the fastest route that visits locations among n locations requires n to the factorial possible routes to be examined. So if we're doing anything to n factorial, that means it's too large for us to solve in a reasonable amount of time. So we would need to use heuristics again. Heuristics is a problem solving technique that gets good enough answers, not perfect answers, because it would take too long. Versus A, appending a value to a list of n elements. That would not be very hard to do. So we're looking for something that would be too hard to process, so we'd have to use heuristics to do it. C, performing a binary search for a score. Binary searches are not that hard to apply. Perform a linear search. A linear search is just going one by one. Again, even if the list was really long, the computer could do that really fast. Under which of the following conditions is it most beneficial to use a heuristic approach to solve a problem? Again, when the problem cannot be solved in a reasonable amount of time and an approximate solution is acceptable. That's literally the definition of a heuristic. So C. All right, an online game collects data about each player's performance. The procedure get prediction ID num returns a predicted score for the players with that ID number, which we see here. There's the ID numbers. Assume that all predicted scores are positive. The get prediction takes about 1 minute to return a result. All the other operations happen instantaneously. Okay, so the question really is coming out, which of the following compares execution time of the two versions? So if we look at this one, it's going to run get prediction right here, but it does it for each ID in the list. So if we calculate here, we're going to see that it has 1, 2, 3, 4 IDs. It's going to run a get prediction score for that and apply it to the score. So this really should take about 4 minutes. And then it just displays the top score because it's only running get prediction 4 times. Okay, so that first one was 4 minutes like we said. So version 1's 4 minutes. Next it says ID list. So again, we have 4 different. The top ID is going to get the ID list at 1. So the top ID is scheduled for this first one. It says if get prediction ID, which again, I was a little confused at this at first when I was reading this, but I'm assuming we're just applying to this. ID is like their code for I guess. Again, this is pseudocode, so it's a little different, and they don't start at 0. So normally we would say this is 0, 1, 2, 3 in Java. But in pseudocode, a lot of times they start at 1. So that's how they would actually run it. That's why it says ID list 1. So anyways, we're going to really compare this one to this one. But for the first one, it's going to compare it to itself. And then it's going to do that again, and again. So right there, that's 8 times. So that's 8 minutes in that one piece. And then at the end, it runs it one more time. So that's an additional minute. So you have 9 minutes total of how long this one should take versus 4 minutes. So this is going to take 5 more minutes to run, which is exactly what D says. Okay, so we have a computer program again. We want to, every time the computer control player has a turn, the game runs slowly because the computer evaluates all potential moves and selects the best one, which the following best describes the possibility of improving the running speed of the game. Okay. Again, you have to think about it. We have not learned about memory or processors. We haven't learned any hardware. If there's any questions on hardware, the answer is probably not that because we haven't talked about hardware. We've only talked about software. So please don't answer anything with, we need to improve the memory of the computer, which that would probably work, but we're not going to do that. A, the game's running speed can only be improved if the player is played between two humans. No, we could come up with a better solution. The answer, obviously, here is the game's running speed might be improved by using process finds approximate solutions. Again, this is our answer of heuristics. So whenever we can use heuristics, when we're trying to find all the possible ways something can happen is going to be very time consuming. So if we can use heuristics, that's going to speed things up. The game's running speed cannot be improved because computers can only be programmed to find the best possible solution. That's not true. We can get approximate solutions. The game's running speed cannot be improved because the game is an example of an algorithm that does not run in a reasonable amount of time. No, again, we can rewrite it. So again, heuristics is going to save us time. Save us time and money. A graphic artist uses a program to draw geometric shapes. The program uses an algorithm that draws a shape based on the input from the artist. The table shows the approximate number of steps. So the question here is, how are we increasing? If I draw 4 shapes, how many steps does it take? Well, does this run in a reasonable amount of time? The first one, it says, the algorithm runs in a reasonable amount of time because it uses approximate n steps to draw n shapes. Well, that's not true. If that was true, these numbers would be the same. So about how far apart are these? Well, if we did 4 squared, that would be about, 16? Which is pretty close. 5 squared is about 25. This would be 36 if we were to square it, and 49. So it's approximately squaring these. That's why it says the algorithm runs in a reasonable amount of time because it uses approximately n squared steps to draw n shapes, which that's fine. We can compute that easily. What we don't want to compute is we don't want to compute something that's going to do n to the power of or a factorial or something that's to the power of n, so exponential. So exponential and factorial are not reasonable. So these are wrong because they're saying it's unreasonable. N to n, that's no improvement, so that's easy for a computer. Even n squared is okay. It's just factorial we don't want. So if we saw something where it was like a to the n or n to the factorial, we would say unreasonable. Oopsie. Do that a lot. Okay. This one got a little hard to read, I noticed. Company delivered packages by truck, which allowed to minimize the length of the route that each driver must travel in order to reach delivery. 2 different algorithms. So the first one generates all possible routes, computes their length, and selects the shortest possible route. Does not run in a reasonable time. This generates from an arbitrary delivery location, finds the nearest unvisited delivery location, continue creating the route by selecting the nearest unvisited until all locations have been visited. The algorithm does not guarantee the shortest route, but runs in a proportional n squared. So we definitely want to use 2 because it's going to run in a reasonable amount of time. So they all say 2, but let's see why. 2 attempts to use an algorithm approach to solve an otherwise undecidable problem. That is true, but is it the best? Again, here's a question that we get a lot. Which one best categorizes it? Use a heuristic approach. That's for sure a better answer. Algorithm 2 provides no improvement over algorithm 1 because neither algorithm runs in a reasonable time. That one's false. So this one was true. This is just a better answer. This one's just completely false. Algorithm 2 requires a faster computer in order to provide an improvement over algorithm. It doesn't say anything about that. It's all about the program. So that's false. So we did have 2 true answers. B is just the better answer. Okay. Which of the following programs is most likely to benefit from the use of heuristics? Again, finding the shortest route is always kind of the answer to that one. Each algorithm operates on a list containing n elements, which n is a very large integer, which the following runs in a reasonable time. Access the list twice, we're okay with that. List n times, that's fine. Only the first 10. All of them are fine. Again, only if we saw something with a factorial, or if we saw, something, list to the n power or something like that, then that would be a no-go. But that one's fine. All right. A program wrote the code, displayed the elements. There's always at least one number in the list. Okay, so what's going on? Player wants to reduce the number of operations that are performed, which is the best. So let's take a look at it. So he's setting a count at 0 as a sum at 0 for each value in numbers. So number is some list we can't see. So count is going to equal count plus 1. And then the sum is going to equal the sum plus whatever the value is. So we don't know what the value is. So we can pretend that we have some list called numbers, and we could say that, hey, look at in my list there is 4, 5, and 8. Sorry, those are brackets. So I could say that. So this would be 4 plus 0. So I run it, I get 4. Now it's going to repeat this 3 times for this list, if that's true. So after the first run through, so after the first time I run it, my sum would be 4. And then my second run through, my sum is going to be 9. And my third run through, it's going to be 9 plus 8, which is going to be, here we go, sum of 17. I don't need to run line average every single time. I do need to run sum every time because I need to update it, but I don't have to run the average to the end. So I should really just flip-flop these two. That'll save me from running this 3 different times, or however many items I have in the list. So we really want to flip 7 and 8, and that was the suggestion here. If we flip 1 and 2, that does nothing. 5 and 6, you can do it. It doesn't change anything. 6 and 7 actually will break because your sum won't. You want your sum to update before you average. So that's the only one that makes sense. All right, let's move on to the benefits. Okay, me. All right. So again, these are kind of like the tests we just recently took. So there's some sort of application here. Let's go through it. So me as an e-reader application allows you to download and read books. Okay, screen brightness and contrast, choice of typeface, amount of spacing. When the user launches the app scans the user's face, and facial recognition software determines the user identity. Once the user has been identified, then it uses personal preference. Which of the following is most likely to be beneficial? Users with visually impaired may be able to easily read or listen to books, and that's all going to be from this top part right here. Users may have reduced risk of the application being used in unintended ways. Not really. May have reduced risk of biometric data. Again, benefit is like, why was it made? What was its purpose for? The whole identification is just to make it log in. From the perspective of the application developer, which of the following is most likely a benefit of storing all user data in a database? They can analyze the database to make improvements to the application. That's good. The developer can analyze the data and ensure that no patterns emerged in the data. Doesn't seem like it makes much sense to them if that would happen. C, the developers can reduce the amount of data storage. I would actually increase their data storage. That makes no sense. Developers can reduce the need for data encryption. That is definitely not true. They're going to have data encryption. Okay, run route, fitness app, cool, on your phone, GPS, beginning the run, shows you the distance, all the applications suggest a runner, basic route account is free, but displays advertisements that are targeted, blah, 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 blah. Cool. Which of the following is most likely to be a benefit to the user? Well, the user may see health benefits as a result of the application encouraging them to exercise. Very good. Versus the other one, the application allows users to identify all their users. Again, nice, but that's probably not the main point. The main point is to get people out and running. User's application may be able to easily identify all other users in a particular area. Again, not so great. Users of application who live in a rural area have the ability to use all the features of the application, even when they do not have internet and geo connectivity. That is nice, but the main benefit, again, you're looking for what's the main purpose. Why did they design it? And it's probably for get more people to run. Businesses have the ability to target advertisements to different groups of people. Which of the following is least likely to receive targeted advertisements? And again, that's the people with a premium account, because it literally did say a basic account is free, but it displays advertisements. Okay, so I'm assuming the non-basic one, which it says right here, removes advertisements. So that's the one that we want to select. Least likely to receive premium accounts. Done. All right, chain of retail stores manage telephone calls. I think we did this one together in class, I believe. So I think we already did this one. So I'm going to skip that. Okay. For questions or incomplete statements, 2 of the suggested answers are correct. For this question, you must select both correct answers are earned credit, no partial credit is earned. So they're kind of interesting questions. So which of the following statement describes how cloud computing has affected internet communication? Okay, so we want to select 2. Cloud computing has eliminated the need to provide redundancy in internet routing. No. Cloud computing has nothing to do with internet routing, so that's not true. Cloud computing has helped enhance collaboration. That is true. Cloud computing is when computers can work together through the cloud. Cloud computing has introduced new data security concerns. More information is available to more people. That's going to be a concern. Cloud computing has reduced concerns about intellectual property. It's probably increased that. So these are false, but those are true. Sometimes they're all true. You just have to select the best ones. A free online encyclopedia contains articles that can be written and edited by any user. Which of the following? Oh, what is that called? Wikipedia. Which of the following are advantages of the online encyclopedia? Well, the ability to easily check the encyclopedia is free for copyrighted content. The ability to ensure the encyclopedia content is the same every time it's accessed. That's probably not going to be true because it can be updated. And that's going to be hard to also check for copyrighted content. But the ability to have a large number of perspectives, yes. The ability to quickly update, yes. Okay. I remember on Wikipedia, it's like the Olympics were happening, and you could go on Wikipedia one day, and then the next day it would be totally updated because new people won gold, and they would update it right away, which is very cool. If you had a paper one, that would not happen. Both online newspapers and social media websites are used to distribute information on the internet. Which of the following best describes an advantage that online newspapers have over social media? And the key here, or at least it should be, this time we should say, credible online newspapers, but credibility to the information distributed. They should have peer-reviewed stuff versus social media websites don't have to. I would say all of them provide it widely accessible, low cost, and information simultaneously is true for all of them, but more credibility to uh, online newspapers than social media websites. Because I go on a social media website and make up stuff. All right, a software development company has created an application called File Cleanup. When the application is run on a user device, it searches for all files that have not been accessed in the past month, stores them on the company's web server, and deletes them from the user's device. It runs once a day. Users have the ability to manually retrieve files from the server if they are needed. Which of the following is most likely to be harmful effect of using file cleanup? Okay, so we see 2 about internet connectivity and 2 about reliability. So if it prevents users from accessing frequently used files when there's no internet. Now that is not true because if it was frequently used, then it wouldn't remove it from your computer. It prevents users from accessing infrequently used files. That is true. Okay, that's definitely true. And again, sometimes you have to say most likely, so these others might be true. It prevents users from accessing frequent files when, no, again, that's not true. It prevents users from accessing infrequently used files when there's reliable internet connectivity. Well, again, that's false because there is reliable internet connectivity, so they should get access to the web server to get to it. So the only one true is B. Which of the following best describes the purpose of machine learning? Okay, so the question or incomplete statement below is followed by 4 suggested answers. Select the one that is best in each case. Okay, so machine learning analyzes large data set, recognizes patterns, make predictions. Machine learning does that, yes, that is true. To automatically translate algorithms from natural language to machine language. That's not the purpose of machine learning. That's just doing an algorithm. To determine whether an algorithm can be constructed to answer yes or no for all possible inputs. Again, that would just be an algorithm. It's not learning. It needs to analyze stuff. To find approximate solutions that would otherwise agree. That's heuristic. Again, just an algorithm type. That's the only one that makes sense. Was that it? That's it. Cool. Last one. What is it? Data compression. What's up? Open up, open up. Okay. How many do we have on data compression? 12. Let's do this. Okay. So a lot of lossless and lossy questions. So lossless, nothing gets lost. Lossy, everything gets lost. Can't compress lossy we can compress lossy more. Lossless, we can't. A lossless compression can guarantee reconstruction, while lossy cannot. Done. So we have ASCII, cool. What ASCII character is represented by binary to number 1001010. So this one's interesting. I don't know why I put it in this category. This should have been under binary, but that's 74. Again, if that last number is 0, we know it's an even number. So I know I is wrong. It could have been H because that's an even number, and K is an odd number. So it had to be H or J. Just really quick looking at the last number. If it's 0, it's even. If it's 1, it's odd. And then, yeah, just do your little deal. You know what I mean? Flippy do. The user wants to save a data file on an online storage site. The user wants to reduce the size of the file if possible. It wants to be able to completely restore the file. That means lossless. Okay, so anything with lossy, we don't want. Not lossy. Don't want to do both. Uploading the original without any compression. No, he probably wants to compress it because he wants to reduce the size. So A is the only one that makes sense. Bam. All right, byte pair encoding is a data encoding technique. So we never talked about byte pairing coding, or at least we didn't use those words. So you'll see a lot of this on the AP exam. You're like, we never talked about this, because sometimes they're just introducing a concept that we can then discuss, which we have talked about. The encoding algorithm looks for pairs of characters that appear in the string more than once and replaces them. Each instance for a pair with a corresponding character does not appear. The algorithm saves a list containing the mapping characters. So we actually did an example of this when we were trying to compress those songs and poems, and we were seeing who could get the highest compression rate. So this is the best wish. It can be encoded like this, where th is repeating. Oh no, I guess it's just repeating twice. And is repeating 1, 2, 3 times. Which of the following is best? Which of the following statement about byte pair encoding is true? Byte pair is lossy. We don't lose any information with this. So if you see lossy, that's definitely wrong. It's lossless. So it's one of these two. It's an example of lossless. We don't lose any information because an encoding string can be restored. Yes. Byte is an example of lossless because it can be used to transmit message. So we do not consider this a form of encryption. This is just an example of compression. So don't confuse compression with encryption. Compression makes something smaller. Encryption makes it so you your message is secure to send. Which of the following is true about data compression? There are trade-offs involved in choosing. Yes, 100% trade-offs. Data compression is only useful for files being transmitted. Not true. You might just want to save it on your hard drive and never share it online. Regardless of compression, once a data file is compressed, it cannot be restored. It can be if it's lossless. Sending a compressed file ensures the content of the file cannot be intercepted. Again, compression is not an example of encryption, so that's not true. So D is the only correct answer. Person wants to transmit an audio file. Which of the following scenarios best illustrates the use of lossless compression? The device compresses the audio file before transmitting it to a second device. The second device restores it to its original versions. That's exactly what it does. This removes details. If it's removing details, that's lossless. Or sorry, lossy. We lost something. Don't like that. The second device removes metadata. So something's been lost. Nope, that's not lossless. Device transmits the original audio file. Place the transmitted file. It doesn't even compress it. So we need to show compression. So the one that makes sense is A, which obviously is the answer. Which of the following situations would be most appropriate to choose lossy over lossless? Storing music files on a smartphone. Yeah. Again, we say lossy is going to make it smaller. And when you don't care as much about the quality, then that's what you want. Smartphones typically have less memory, but actually now our phones are getting more and more heavy, so maybe you can. Most people stream their music anyway, so who stores music files? I don't. All right. A media librarian is at a movie studio is planning to save digital video files for archival purposes. The movie studio would like to be able to access full quality videos if they need. Which of the following action is least likely to support the goal? Well, if you want full quality, you don't want lossy. So lossy is probably the least likely to help you, which is this one. Store media that can be expanded. Use a system that incorporates redundancy. I mean, those would help. Using video formats that conform to publishing, I mean, that would help. Lossy is the only thing that's not going to help. Digital images are often represented by red, green, and blue, RGB. A photographer is manipulating the digital image and overwriting the original image, which the following described as lossless. So again, we're not going to lose anything. So let's go ahead and look at this. Compressing image away that may lose information. Okay. You done. Creating the grayscale of an image by averaging the amount of red, green, and blue. Assign a new value. The new value of pixels represents ranging from black to white. So we can't get it back though. So we did lose it. Create the negative image by creating a new RGB triplet for each pixel in which the value is calculated by subtracting the original value of 255. The negative image is reversed from the original. Light areas appear dark and colors are reversed. So since you're doing something to all of them, you could reverse that process. Modify part of the image by taking pixels in one part of the picture and copying them to pixels in another part of the picture. That's going to keep it. We're going to lose some information there because you're copying it. So no bueno. I could see C and D though. I could see you thinking maybe this one's good. So that could be like a toss-up question. But this one, since we're doing the same thing to every pixel, we can reverse that much easier. Does it say? Yeah, we can reverse it. So that's key. Here's another one of those data compression. So we don't have to read all this because we already did that. Which of the following is not possible in a byte pair to shorten the length? Well, here we go. AN. You can shorten that. ME. You could shorten that. HER. So this one, can we get anything? LE, nope. EV, nope. So there's nothing that repeats, so that's the only one that can't do better. Programmer is developing software for social media. The programmer is planning to use compression when users send attachments, which I find is true about the use of compression. Lossy provides greater reduction in transmission time. That is true. Lossless, a video will save more space. No, that's not true. That is false. Lossless compression of an image file would generally result in a file that is an equal size to the original. No, then why would it be compressed? That doesn't make sense. Compression makes smaller, not same size. Sound clips compressed with lossy compression for storage on a platform can be restored to their original. No, not lossy. Lossless can, so that's false. I like when there's 3 false and 1 true, but sometimes there's 2 true and 2 false, and you gotta go with the better true answer. That's harder. This one should have probably been in the bit one, but we have 32-bit integers to count the number of times each video has been played. The website is planning to change to 64 bits. We're adding 32 bits, so it's 2 to the 32 power. So this was probably should have gone on the bit one. But there it is. All right, guys. I hope you enjoyed the video. I hope it wasn't too long.